going to quickly do the graphs of decay since they're very similar. Between, okay, ladies and gentlemen, to have exponential decay means you're multiplying by a fraction or a decimal between 0 and 1. Okay, so the parent function is really the same, where b is between 0 and 1. Let's talk cookies real quick. What if you started with, I don't know, a half a cookie? And you're going to cut that cookie in half every single time. It's just going to get smaller and smaller, isn't it? But it's never going to go away. Okay, you just keep breaking it in half. It just keeps getting smaller and smaller and smaller and smaller and smaller. That's exponential decay. So, cookie. Okay, so let's just make a quick table representing what happens there. I am going to have a -2, but we'll get to that in a minute. So if we had a half a cookie and we didn't break it in half, how much would we still have? Half a cookie. This is 0. Actually, we'd have a full cookie, which doesn't really work, does it? But that's okay. We won't think of it that way. If we started with 1/2 cookie, we're still going to have a half a cookie, correct? If I raise it to the second power, what am I going to have? I'm going to break it in half. I'm going to have 1/4. Correct? 1/2 times 1/2. Now, let's think about what happens if it was -2, which doesn't really work with our cookie situation. But you've got to remember what you do with negative exponents there, correct? You put the -2 on both of them, which consequently would make it look like this after you flip those, right? Which has a value of 4, doesn't it? That's why it starts high and goes down. Now, this is the same thing. It passes through 0, 1, and it passes through 1b. Here, my b was 1/2, so over 1, 1/2. But it never, ever, ever goes below the x-axis. That's my asymptote. Starts up here, goes down, boom. That's decay. It's getting smaller and smaller and smaller. The range is always going to be what? In any exponential function? All reals. In the range here, all the y's are greater than what? For this one. Yep. Same thing. All right, let's graph it. You again have to be able to recognize that this exponential function is going to be growth or decay. How can you tell here? It's decay because b is between 0 and 1. B is between 0 and 1. Okay, so you have to recognize that. All right, so let's plug in 0. If we plug in 0, what's our output going to be? 2. If we plug in 1, ooh, 2 times 3/4 is what? It is, again, 1.5. 6 over 4. 6 over 4 is 1.5. Then, from right to left, draw a curve that starts, well, let's just plot these points first. 0, 2, over 1, up 1.5. Does the asymptote change here? Has there been a vertical translation at all? No, so my asymptote's still going to be what? It's still going to be here. Okay? So then you just draw a curve that starts up in quadrant 2, passes through the 2 points, and moves down to the right, staying above the x-axis. So just kind of sketch it. We're not going to be super particular about a bunch of points. We're looking for 2 points and that you don't cross over the asymptote. Cool? Okay, turn it over. Let's add a translation, and then we'll do some application problems. So it's basically the same thing. This is H, this is K. The basic function, again, is this. Y equals 2 to the 3/5 times 3/5 to the x. Plug in 0 to this basic function. What do you get? 2. 3/5 to the 0 is 1 times 2. Plug in 1, you get a funky fraction, and it is 6/5. Okay? Now the translation, what's happening to my graph here? It's going to the right, how many? Right 1, based on h, and it's going up 1. So that means I add 1 to x and 1 to y. So my new points would be 1 and 3. Add 1 to x, which would be 2, and add 1 to y. I'm adding a 5/5 to y, which would be what? 11/5. It's a little over 2, isn't it? A little bit over 2. What's my asymptote? It's based on k, so what's my asymptote? Y equals 1. So let's sketch that. That's my asymptote. It will not go below that. The domain is going to be all reals. The range, what's my range going to be? It's based on the asymptote, right? It's going to be everything greater than 1. So we plot these 2 points here, 1 and 3. And 2 and a little bit over 2. Something like that. That's it, okay? Graphing's pretty quick. All right, you got to know the exponential population decay, money loss. You may lose money someday. You need to know this one as well. It's not all that different, really. It's just a minus in there. A new television costs $1,200. The value of the television decreases by 21% per year. And that kind of makes sense, doesn't it? Think about it. You know how rapidly technology is improving. The value of your TV goes down pretty quick because there's always new ones out there that are bigger and better. So what's R going to be? 0.21. This is my A. Write an exponential decay model. That means you leave T. If you're writing a model. You leave TT. You want to be able to put any year in there and figure out the value. Given the television's value after T years. So Y equals the starting amount. And then you do 1 minus your rate. You leave T as T. You're writing a model here. Anything. The decimal's here, right? Okay, that's all right. Now, I'm actually going to write this the better way. I'm going to do the subtraction here. Y equals 1,200, and it's 0.79 to the T. If you were given this model, you would need to recognize whether it's decay or growth, and how do you do that? Look at that, right? That's less than 1, so it's decay. Estimate the value of the TV after 2 years. So what do? Plug in T for 2. And after 2 years, it would only be $748.92. So it went down quite a bit in 2 years. All right, a city's population in 1970 was 250,000. The population of the city decayed at a rate of 2.7. That means my R is going to be what? 0.027. Estimate the city population in 1990. Oh, wait a minute. So from 1970 to 1990, how many years is that? T equals 20. Okay. So now we're just going to use the equation here. Y equals, my starting amount was 250,000. And I did 1 minus the decay rate to the 20. Try and get that number on your calculator. See if you get the same number I do. Make sure everybody's using their calculators right. Yeah, yeah? 10 minutes, that was better, wasn't it?